Hey everyone, and welcome to today's Explainer. We're going to be looking right under the hood of something that literally powers the modern internet, but it often just gets totally taken for granted. We're talking about network routing. Today we're going to demystify how standard Linux systems actually handle these really complex networking tasks. It's a completely fascinating journey, so let's just dive right in.
Okay, to kick things off, let's try shifting your perspective a bit. Just look around your room or your office right now. Do you have a dusty old laptop just sitting in a drawer somewhere? Or maybe a decommissioned basic server? Well, did you know that piece of hardware actually has the latent ability to become a full-blown enterprise-grade router? Yeah, it's true. It isn't just for hosting websites or files. It has this massive hidden networking engine just waiting to be turned on.
And this actually brings us to a massive open secret in the networking industry. If you go out and buy a super high-end commercial networking appliance, there's a very, very high probability you're really just buying a specialized box wrapped around a standard Linux or FreeBSD kernel. Systems like OpenWRT, VOS, pfSense, Cumulus Linux, at their foundation, they rely on the exact same routing capabilities that are sitting right now in a basic Linux server.
All right, so let's jump right into phase one, the hidden super router.
So to really understand how Linux pulls this off, we kind of have to strip things back and ask, what actually is a router at its absolute core? Well, a router's job can be summarized really simply. It helps packets find their way. Imagine your local computer wants to connect to Google. It hands that data packet to its default gateway, which is the router. The router then checks its internal map and decides exactly where that packet needs to go next. That right there is routing.
But here is the truly wild part. You don't actually need to install extra software for this to work on Linux. It natively contains a complete routing core straight out of the box. The IP stack, the routing engine, ARP, NetFilter, traffic control, all of this is built directly into the kernel itself. It is natively a super powerful network operating system.
Moving on to phase 2, awaken the Linux routing soul.
Now you're probably wondering, if it's already in there, why isn't my server acting like a router right this second? Well, by default, Linux absolutely refuses to forward packets, and the reason is simple: strict security. In its default state, IP forwarding is turned completely off. It will only accept packets addressed directly to itself. It will not act as a middleman. So to turn a default Linux machine into a router Linux, we actually have to explicitly flip that switch to on.
And flipping that switch, it's remarkably straightforward. First, you just check your status by reading the IP forward file in the proc file system. If it says 0, routing is off. To awaken it, you simply echo a 1 straight into that exact same file, and boom, temporarily, your machine is a router. Now, to make sure that actually survives a reboot, you just save net.ipv4.ipforward equals 1 into your etc syscontrol file. It's literally one line of text, and it changes the entire nature of the operating system.
Okay, so the brain is awake. Now we need the physical and logical architecture to support it. A basic router requires at least 2 network interfaces. Let's say ETH0 connects out to the external internet and ETH1 connects to your internal LAN. Right alongside that physical setup is the logical core, the routing table. If you run iproute, it shows you exactly how the server is directing traffic, sending local 192.168 traffic out of ETH1 and pushing everything else out of ETH0 straight to the default gateway.
Which brings us to phase 3, NAT, the key to the real internet. Now you might be thinking, great, IP forwarding is on, time to browse the web. Well, actually no, not quite yet. The missing puzzle piece here is NAT, or Network Address Translation. See, your internal network devices use private IP addresses. The global internet has no idea what those are. It cannot route traffic back to them. So NAT solves this huge problem by converting your private internal IP into the Linux router's public-facing IP, right before the packet leaves for the internet.
We can see exactly how this is built in practice using IP tables. Now, I know IP tables can look super intimidating, but it's actually really logical when you break it down. First, we tell the firewall to use the NAT table. Then, we apply the rule right before the packet leaves the system via post routing. We specify that this only applies to traffic going out to the internet on interface ETH0. And finally, the magic word, masquerade. This cleverly disguises the internal device's IP and replaces it with the router's public IP. And with that single command, your internal devices are finally, truly online.
Let's look at phase 4. Build enterprise-grade security.
So we have internet access now, much like a standard home router. But to make this a robust, enterprise-grade setup, it absolutely has to be a secure gateway. And this is the ultimate superpower of Linux. Its routing and firewall capabilities are seamlessly integrated. Using IP tables, you can easily set rules that just drop external attempts to access services like SSH from the internet, while explicitly allowing those exact same services when accessed securely from your internal LAN. And honestly, the enterprise features don't just stop at firewalls. Because it's Linux, you get massive power-ups baked right in. Need to segment different departments? You can easily spin up VLANs directly on your interfaces. Want to make sure your video calls don't drop when someone decides to download a massive file? Just use Linux's traffic control to implement QoS, or quality of service, to limit bandwidth. Need remote workers to access the network? It natively supports world-class VPN tech like WireGuard, IPsec, and OpenVPN. The whole shebang is just right there.
Finally, let's explore Phase 5, driving cloud and future networks.
It is literally staggering what a simple Linux box can do, but we need to scale our perspective up even larger. When you look at major ISPs and massive data centers, they often completely bypass proprietary hardware and rely directly on Linux routing. By installing software suites like FR Routing or Bird, Linux drops the home router disguise completely. It becomes a full-on, telecom-grade powerhouse, capable of running the heavy-duty protocols that hold the internet together, stuff like BGP and OSPF.
So why does the cloud absolutely love Linux networking? Well, just contrast traditional equipment with the modern Linux approach. Traditional network gear is notoriously rigid, locked down, and heavily reliant on manual command line interface configuration. Linux networking, on the other hand, is completely programmable. It thrives on automation. It can be controlled via APIs, it integrates seamlessly with containers and software-defined networking, and it's literally the absolute core of Kubernetes networking. It has a flexibility that legacy hardware just can't match. And that flexibility? It's pushing boundaries with the absolute hottest tech in modern networking right now, eBPF. This is a revolutionary technology that allows network packets to be processed dynamically and at lightning speed directly within the Linux kernel itself. It completely bypasses the performance limitations of traditional IP tables. Projects like Cilium and Calico are actively using eBPF to just completely rewrite the rules of what a Linux router can achieve in massive cloud-native environments. It's a total game changer.
Man, we have covered an immense amount of ground today, haven't we? From flipping a single text file switch to enable IP forwarding, all the way up to powering the global cloud with BGP and eBPF. So as we wrap up, I want to leave you with this provocative thought. If a basic out-of-the-box Linux kernel is quietly acting as the hidden engine of the modern internet, what other incredible superpowers are currently sleeping in your servers, just waiting for you to awaken them? Thank you so much for joining me on this explainer. Keep exploring, and I'll see you next time.